So we don't always have to use or remember a difference of two squares and factor quadratics to solve them. We can also use solving by using the square root, but there's a couple things we need to talk about first. So what is 3 squared? It is positive 9. What is negative 3 squared? It is also positive 9. So what we need to realize is that when we take the square root of 9, the answer could be positive 3 or a negative 3. We actually have 2. So when we're finding our solutions, when we're solving a quadratic, we need to remember that it's going to be 2 possibilities. Also, we cannot forget that the square root of negative 1 is represented by the letter I. So, first of all, you cannot use square root to solve if there is an x term. Okay, it just has to be x squared and then a constant or some constant, something like that. The first step is like the absolute value. We want to isolate that x squared term. We want to get it by itself. Then we can take the square root of both sides and we'll have our answer. So take a look at example number 1. The x squared is all by itself. So all we have to do is take the square root of both sides. And if you remember, the square root and the square are inverses, and that's why we use it. That leaves us with just the x. And then we have the square root of negative 1, which we know is I. But don't forget, it's the positive and the negative version of I. So that gives us 2 solutions. Okay. If we look at number 2, the first thing we have to do to isolate the x squared is to divide by the negative 2. So that gives me x squared equals 16 divided by negative 2 is negative 8. And then, since the x squared is isolated, we are ready to take the square root of both sides. So now I have the x is the square root of negative 8. And I have to see if I can simplify that. So I have 1 times 8 and 2 times 4. And I did find a perfect square there. So I have the square root of negative 1 times 2 times 4. The square root of negative 1 we know is I. The square root of 2 is stuck there. And the square root of 4 is 2. So that's out of the radical. And it's the positive and the negative solution. So that's 2 solutions. Positive 2i times the square root of 2 and negative 2i times the square root of 2. So if we look at example number 3, to isolate the x squared term, we'll subtract 6. That leaves me with x squared here. And 105 minus 6 is 99. So I will take the square root of both sides. This leaves me with the x here. And then I have the square root of 99. So let's see what we can do with this. 1 times 99, 3 times 33, 4, 5, 6, 7, 9 times 11, and that should be it. So I have a 9 here. So if I split this up into the square root of 9 times 11, the square root of 9 is 3. The square root of 11 is stuck. So I have the positive and negative 3 times the square root of 11. Again, this is 2 solutions. 3 times the square root of 11 and negative 3 times the square root of 11. All right, looking at number 4. To isolate this x squared term, I'm going to subtract the 7. That leaves me with 6v squared equal to negative 23. And then I will divide both sides by 6. So I get b squared equals negative 23 divided by 6. All right, if I take the square root of both sides, this is prime. This is not a perfect square, but I do have the square root of this negative, so I'm going to go ahead and put an I there. And this is what I have. But if you remember, we are not allowed to have a radical in the denominator. So I'm going to have to multiply the top and the bottom by the square root of 6. All right, so when we have 23 times 6, that gives us 138. So we have plus or minus I times the square root of 138 divided by the square root of 36. And the square root of 6 is, or the square root of 36 is 6. So the solution to number 4 is the positive I times the square root of 138 divided by 6, and then negative I times the square root of 138 divided by 6. All right, number 5. Here's my x squared term, so I will subtract the 9 first. 13 minus 9 is 4. And then I'll divide by the 16. So that leaves me with x squared equals 1/4. And so now I'm ready to take the square root of both sides to get x equals, and you guys tend to get upset when you see a fraction under the radical, but think about it. What is the square root of 1? 1. What is the square root of 4? 2. So a positive 1/2 and a negative 1/2 are my zeros, my x-intercepts. All righty. This is our x squared term, so it is already isolated. So I will take the square root of both sides now. So that will leave me with the x minus 6, what's on the inside, and this leaves me with the square root of 17, positive and negative. So when I add the 6 over, it's like I need 2 equations actually, so I'm going to write it so I can illustrate it. I have x minus 6 equals a positive square root of 17, and I have x minus 6 equals a negative square root of 17. So that when I add the 6 over, here I have 6 plus the square root of 17. And when I add the 6 over here, I have 6 minus the square root of 17. Those are my 2 solutions. All right, now if a function has a radical or a complex zero solution, root, x-intercept, then the conjugate is also a 0. Okay, so if I have an x-intercept, which, at -3 plus the square root of 7, I also have another x-intercept at -3 minus the square root of 7. If I have an x or a solution here, negative 1 minus 2i, I will also have the solution negative 1 plus 2i. Here, if I have a positive square root of 10, I also have a negative square root of 10. And for this one, the other solution would be negative 1 minus 2 times the square root of 2.